program, so you have more resolution as you look at the closer dates, and it gets fuzzier and fuzzier to look out. But if you were looking at the funding profile we have and the type of program we're doing, you would expect in the 2030-ish time frame that you could be at Mars. But that's pretty far out, so it's hard to promise a date.
I'm Patrick Lynch with the Daily Press. I'm curious if you all could talk a little bit more about how much you're looking at sort of the Apollo and Saturn templates for the design of the new crew launch and other vehicles. And I guess, what are you building on? What are you refining? That kind of thing. And then as part of that, just sort of a specific question. I'm curious why the crew launch vehicle is now built to land on Earth as opposed to in the water. Is that a safety or a logistics thing, or what?
These are all real interesting questions. Yeah. There's. I'll take a cut at some of those questions. The Apollo method of going to the moon was all done in one vehicle. So it was one large vehicle. If you want to have more capability to the moon, we were able to put 2 people on the moon for several days at an equatorial site, around the center of the moon. We want to be able to go anywhere on the moon. We want to send more people and get more work done, so we need more performance. So we need more payload delivered to low Earth orbits. So you need something more than just the Saturn V could deliver. So while the Ares V can deliver a similar weight, in fact a little more than a Saturn V, the combination of the medium launcher, which is the Ares 1, launching the crew, gives you more capability on your way to the moon. So we get more capability there. It also splits up the risk, and Greg can kind of talk about the similarities and differences between how we protected the crew in the Saturn V and how we're going to protect the crew in Ares 1. The Ares 1 design was evolved from the concept that we wanted to get at least an order of magnitude better protection for the crew than we have today in the current space shuttle system. Greg, if you want to address some of that.
Sure. Well, for the launch abort system design itself, we looked at the Apollo design, and we've made a couple of modifications to that to provide additional capability. First off, we provided an active control system to help us control the trajectory of the launch abort vehicle once we may have to depart from that launch vehicle itself. Apollo used what we think of as a passive system. That is, it fired an abort motor, and then it used a canard system to help with the aerodynamic drag to reorient the vehicle. And it did have one motor that would help pitch it over in the event that they had to use a launch abort system from the pad. But that we really didn't consider that an active system. In the system we have today, in order to account for more dispersions, if you will, off of the trajectory that we would nominally fly, we have this attitude control motor, and that will provide us the capability to reorient a trajectory to carry the crew to safety. We also have enhanced the abort motor itself. The Apollo system had a truss structure that separated the abort motor from the crew module, such that once the abort motor fired, the ejecti coming out of the abort motor did not erode away the crew module. We've used something called a reverse flow nozzle system, whereby we place our nozzles at the top of the abort motor instead of at the bottom of the motor where Apollo did. That gives us an opportunity to provide more propellant in the case, thereby taking away that truss system, and giving us additional capabilities for the abort motor. We think overall we've designed this system to handle a lot more scenarios in which we may have to provide for an abort during the ascent of the Orion spacecraft, and I think we have a much more capable system to help protect the crew and provide that factor of safety that NASA's been looking for beyond that of Apollo.
You asked specifically about land versus water. The basic requirement is when we do an abort, you have to be able to land on either. You can't predict where you're going to end up. It depends on where you have to abort. So you might land on land, you might land on water. So at a minimum, you must protect the crew for a land or water. The nominal reentry right now, we're looking at land as the basis, and it's a combination of safety. What's the life cycle cost? How much reusability do you believe you're going to be able to get out of the system? And so there's still trades going on. We're still well before the preliminary design reviews. We just finished all the system requirements reviews. And so there's still a lot of trades going on looking at that, but the baseline is to look at landing sites, but we're still looking at the advantages and disadvantages of landing on water versus land. But at a minimum, you have to be able to survive both.
Hi there, Cheryl Tan, Wavy TV. I think it's safe to say that there's a pretty big wow factor in some of the things that you've shown us today. From what it sounds like, you plan on having an outpost on the moon in the next 15 years or so. Is that correct?
Yes.
What motivates you scientists behind the scenes?
Well, I can start. If you're asking what motivates me to do the best job I can on a daily basis. In 1997, I was working a shuttle mission flying a payload to Mir. And one of the crew members who was going to go outside and retrieve the experiment for us was Vladimir Titov. And as you may know, he is one of two individuals who has actually survived an abort, where a launch abort system had to activate. And he described to me a story of sitting in the capsule, and at the time there had been a failure in the system that should have automatically pulled him away. And fortunately, a backup system worked with a ground controller, and they were. You know, seeing the look in the gentleman's face and just listening to his story reminds me every day of why I need to be here and do the best job I can, and that motivates me. And the team that I've mentioned previously that's working on this, they're all motivated as well, because we think about how it could be friends, family, or friends of our friends one day in that particular vehicle. And we want to give them the best opportunity we can to come home safely from any emergency that may happen.
From a technology and engineering point of view, I think the engineers at NASA, an aspiration of all of them is to have their flight hardware end up in orbit. I think every one of us who's ever tinkered in the lab always thinks, how cool would this be if we can get it into space? And what we're offering now with these programs is the ability to enable that. With the focus of the technology program and the way it is, everything that we're developing now, while it may not eventually end up in space because the government isn't in the business of building everything. Of course, the contractors are doing most of the hardware for flight. The fact is you get your fingerprint on it. The engineers, their designs, their sweat, their blood, and their sleepless nights are in this work. And that's what motivates them. Is that, you know, as an engineer, that's what excites people, and that's what excites me, is the fact that the things that we're doing can influence the future systems. And we're talking about something that's multi-generational here. This isn't just a one-shot deal. We're talking about the next generation of vehicles. That's a big deal. I mean, the folks who did shuttle back in 30, 40 years ago had the same aspirations, had the same feelings. It's the culture of NASA. It's the way that we do our business that inspires us and keeps us moving. And we hope that everybody else shares that as well, because this is our future, and this is what exploration is about. It's what's driven us as a human being, as a humankind, and it's what's going to continue us on for the future.
And why does NASA want to explore? Let me hark back to the picture of the Godspeed coming into Jamestown. For the same reason that John Smith came here 400 years ago. We want to reach out, understand what is there, and also exploit what is there. Bring the moon, bring Mars into the economic sphere of the Earth to extend mankind's reach into our solar system. Probably we all share the hope that several generations hence, people building on our heritage will extend our reach even beyond the solar system.
And I have a kind of a unique perspective. I've had the honor of actually flying the shuttle 4 times to space, and thanks to thousands of folks like this, have been able to do that and come back and tell the tale. If I were to sum it up in one line, is everything that we do and everything that these folks pour blood, sweat, and tears over to make happen, in the end makes life better for all of us here at Earth. It's better for us and for our children and our children's children. It provides opportunities, it provides motivation, and it provides benefits